Hello everyone, very warm welcome to all of you on the platform of KSG. My name is Akhilesh. I'm here, Geography, Faculty of Geography at KSG, India. In these video lecture series, we are going to discuss about some very important topic related with optional geography as well as general studies. So you might have seen those videos. Now, today I'm going to discuss about the tricellular meridional circulation, the primary circulation which is taking place on this earth surface. In this circulation you will find that there are three cells that has been formed because of different pressure belt which is developed on the earth surface, and due to these pressure belt different types of horizontal movement of air as well as vertical movement of air are going to be there, and they constitute cells and planetary winds. So in today's video we are going to have the understanding of first pressure belt, then we will go for tricellular meridional circulation. Indeed, which kind of force, what are the forces responsible for this circulation is going to be discussed in detail. So please follow and get tuned in with the video. This will give you the better understanding of entire primary circulation. So let's start with the forces responsible for movement of air. So air movement, air movement. Two type of air movement you will find. One is horizontal movement, horizontal movement of air, this is called as wind, and second one is vertical movement of air, vertical movement, and vertical movement is called as air current. Fine. So horizontal movement and vertical movement, what are the forces responsible for this movement? First and foremost is what? Pressure gradient force. Pressure gradient force. Simply, this pressure gradient force is difference in the pressure of atmospheric pressure of particular area. Atmospheric pressure, you all have this idea that the column of the atmospheric gas is going to exert a certain kind of pressure at sea level at a unit area, that is called as atmospheric pressure. And when it was measured by using barometer, it came up to 76 centimeter column of the mercury. It is equal to 76 centimeter column of the mercury at sea level. Or you can say this is what? 760 mm Hg. So this is what atmospheric pressure, and this atmospheric pressure varies from one place to other place because it depends upon temperature. When there is high temperature, there is low pressure. High temperature always find low pressure at sea level, or you can say on the surface of the earth. Fine. Why? Because of thermal expansion. There is thermal expansion, and due to this thermal expansion, what happened? Air expanded and become lighter. So lighter air tend to rise. Lighter air. So suppose that this is the air of certain area where temperature get heated, means this area get high temperature, and then there is thermal expansion, this air start moving up. So due to that, in this zone a void is going to be created, void, and this void is going to be represented by low pressure. Fine. Low pressure. So do remember this thermal expansion, and when there is low temperature, what happened? There is thermal contraction. Thermal contraction. Air get contracted, air become denser, air become heavier, and heavier air tends to sink, and sinking air creates high pressure. Sinking air creates high pressure. When air become denser, air become heavier, and it starts sinking, and hence what happened, there is high pressure. Okay, there is high pressure. So when there is high pressure, that means there will be low temperature. This relationship stand at the sea level, or you can say on the ground surface near about sea level. But once the latitude start increasing, that means there is high temperature and there is low pressure. This stand everywhere on the ground nearby sea level. But once you go for certain height, suppose that this is the mountain or hill, you are, this is sea level. So at sea level there will be high temperature, so there will be low pressure. But once you start moving up and you are reaching up to height of say 5 kilometer, then there will be temperature and the temperature is going to be low. So low temperature represent high pressure, but what happened, there is low pressure also. So at this particular height there is low pressure. Do remember, so this low pressure attributed to the air column which is left over in this 5 kilometer height. This air column is not at all exerting atmospheric pressure. So the relationship between temperature and pressure is like that. On certain height there is a decrease in temperature because of the reason of concentration of gases. More and more greenhouse gases are concentrated in lower atmosphere. As we move up, their concentration is going to be decreased. Fine. So at certain height you are going to have this low temperature, but low temperature is not going to be related with high pressure over here. The pressure also get lowered because this much column of air is not going to exert any pressure. And you all have this idea that 50% of the atmospheric gaseous composition lies within 5.6 kilometer of atmosphere. 50%. That means this 50% pressure is going to be reduced already. So at this height only 50% gases are left to exert pressure. Fine. That's why the low pressure are there at certain height. Do remember this. Fine. And because of the temperature difference as well as altitudinal difference, we are going to have differences in pressure, and this difference in pressure is called as pressure gradient force. So pressure gradient force a gradient is created in pressure because of difference in pressure. So high pressure minus low pressure will give you the pressure change, and this is what pressure gradient force. Second force which is responsible for the movement or which is affecting the movement, horizontal movement of air is Coriolis force. Coriolis force. And this Coriolis force is responsible, this is what? Apparent frictional drag. It is not a true force. It is apparent frictional drag. It is because of rotation of earth and sphericity of earth. So this is not a true force, it is a pseudo force acting in northern hemisphere and deflect anything moving horizontally towards its right and right hand side, and in southern hemisphere anything moving horizontally is going to be deflected towards left. Fine. This is Coriolis force. It's a pseudo force. It is an apparent frictional drag, it is because of the rotation of earth and simultaneously because of the sphericity of the earth. Once you go for the derivation of this uh, deflection and the path of the air, you require some mathematical attributes, and it requires at least 5-6 pages. That's why, being a geography student, my advice is to remember it, what is the Farrell's law, because once you go for the derivation, mathematical derivation, you have to take care of the different points on the earth's surface which is moving at different speed, because rotation of earth is giving the highest speed to any point which is on equator. And once we are moving towards pole, the speed to cover that very periphery is going to be reduced. Why? Because the polar this equatorial circumference is going to be the highest, and any point which is moving at equator will take 24 hours, and any point which is moving at 66 degree north or south is moving on a smaller circle, certainly in 24 minutes. So obviously the speed is going to be lower, and this relative speed is responsible for such kind of deflection. And do remember, once you go for derivation, it requires some mathematical aptitude, and that is not the part of your optional as well as general studies. That's why we go for what? Remembering it in a form of Farrell's law. Farrell's law states that anything moving, anything including air, it is water, means ocean current, moving horizontally in northern hemisphere get deflected towards its right, or in southern hemisphere get deflected towards its left. This is what Farrell's law. Fine. Second force is Coriolis force. The third important force which is acting or affecting the movement of air is frictional force. Frictional force. Fine. This frictional force, basically it is a frictional force which always act opposite to the movement of the air, opposite to the direction of movement of the air, and it is depending upon the type of surface over which the air is moving. The type of surface may vary, maybe a water body, extensive water body will be there, maybe an area of grassland, parkland, or there may be some area of dense forest, maybe hilly area or something like that. So you are going to have different types of surfaces on the ground, and movement of air is taking place over it. So this is like this. And because of different surface, there is continuous frictional drag which is acting upon this air movement, and that is always going to be opposite in its direction. So if you see, this is what? Frictional force. Frictional force. If wind movement is taking place near the earth's surface, there is frictional force which is always acting in the opposite direction of the wind movement. Fine. And it depends upon the surface also. Suppose that if the surface is going to be homogeneous, just like water surface, what happen? Friction is going to be least possible. But what about hilly area? What about dense forest? Certainly it will give more friction. Fine. That's why in geography you will find that the westerly of southern hemisphere, they are more profound and strong, because southern hemisphere is having lot of water body, less land is there. So because of non-availability of land, or you can say less availability of land and more homogeneous surface, the southern hemisphere westerly winds are going to be stronger, and they are known by their name. पूरे नाम भी रस में रखे हुए हैं, like roaring 40s, furious 50s, shrieking 60s. ये नाम है बच्चे इनके. Why? Because they are so strong. Why they are so strong? Because frictional force is going to be less in southern hemisphere, and that's why you are going to have southern hemisphere westerlies have different names. Okay, homogeneous surface. So frictional force, it is always acting in opposite to the direction of movement of the wind. This is direction of movement of wind, and it is always acting opposite to it. The fourth force, and one thing more, this frictional force is active in lower atmosphere. And not only the surface and the air, but it is also acting between the air interface. So this frictional force is going to be more active in lower atmosphere as the height increases. This frictional force is going to be least, and in upper atmosphere near tropopause you will find almost zero friction. And this equal to zero friction or 10 to 0 friction is responsible for geostrophic wind that will be discussed later phase of this video. Fine. The fourth force, which is responsible for certain kind of deflection or meandering or change in the direction, or it can affect the wind movement, is gravity and buoyancy. Gravity and buoyancy. Fine. You all have this idea, Earth has gravity and it pull certain mass of air moving in upper atmosphere towards down. So what happened? The air which is moving like this is air which is moving in upper atmosphere, dragged by gravity downward. It is moving like this. But what happened? Simultaneously, there is other air that act as cushion. It do what? It give buoyancy to the moving air, and the air start moving up like this. Then there is gravity, and that's why you will find the air which is moving in upper atmosphere is going to have meandering path. A vertical meandering is going to be created. So it is not a straight line. So when we discuss jet streams, especially jet streams are geostrophic wind, then we will find this kind of meandering, especially the polar jet as well as subtropical jet. They go for vertical as well as horizontal meandering. Why this meandering is going on and what are the repercussions of this meandering will be discussed in detail in the class. Fine. You require some more understanding how the jet streams are being formed, where it is going to be formed, how it becomes geostrophic and all. This is not possible to give in this small video. Fine. Okay. So this jet stream, gravity and buoyancy is going to work over here. Gravity is pulling this wind downward, and the air which is not moving but present in atmosphere pushing it upward. So you will find the upper atmospheric circulation or geostrophic wind has a meandering, and that is what? Vertical meandering. And this meandering give special characteristic to these jet streams, and they are going to affect the local weather phenomena, or you can say weather phenomena in particular area. For example, western disturbances. Fine. So it is related with jet stream, heat waves. cold waves. And these jet streams, as well as its meandering, is going to be more stronger and stronger because there is global warming phenomena that is going on. So up to this much understanding you must have in your general studies as well as in your optional subject, so that you can relate the weather phenomena with jet stream. Role of this jet stream in Indian monsoon, the local jet stream, that is what we call easterly jet stream. We'll discuss the role of jet stream in Koteshwaram theory of development of monsoon in the class in detail. So you are going to have all these phenomena, they have a sequence, they have a link, there is a definite cause and effect model. It is already discussed in the book, but deciphering it is a little bit difficult. Not difficult, little bit difficult. So I will discuss in the way that you can have the understanding in better way. So these are the four forces responsible for movement of the air, that is what? Wind movement. In the next video, we will continue this understanding of atmosphere for further detail. Please tune in. Thank you very much for today.